Hello, my name is Dr. Dale Weber, and I'm a research biologist with Vemco. This tutorial is about range testing. The detection range of your tags is highly dependent on absorption and noise heard by your receivers. Here I have listed some of the factors that can affect acoustic range. All of these factors can vary significantly from one location to another, and with time in a particular location. This needs to be taken into account when installing a line of receivers with the objective of detecting all passing fish. While it is possible to predict range under various conditions in the open ocean, the acoustic conditions in many, if not most areas where lines are installed can be quite different. Therefore, it is important to do some range testing prior to deployment of the line. This testing should be carefully planned in order to produce relevant results and should focus on areas and conditions of planned deployment. Regardless of the type of range test you are planning to run, please contact us for advice prior to setup. Our suggested range testing procedure is fairly straightforward. Use a transmitter with power the same as that of the weakest tags to be used. Ideally, fixed delay tags should be used so that you know exactly how many transmissions occurred. Deploy a line of receivers at representative ranges, for example, 1 every 100 meters. The spacing will depend on the environmental conditions at your location and the tag power output. I usually use a VR100 to quickly get a rough idea of the maximum range of the tag, and based on the number of VR2Ws that you have, you can then determine the appropriate spacing. You may wish to space the receivers that are close to the tag line further apart, and use narrower spacing between receivers that are further away from the tag line. Spacing is up for you to decide. Allow the receivers to detect long enough so that representative conditions are encountered. For example, changes in weather and biological and man-made noises. This will be on the order of days or weeks. Seasonal effects, particularly in rivers and estuaries, also need to be considered. This slide illustrates a typical setup. Place the transmitter near one end of the line. Alternatively, if transmitter depth is thought to be a factor, you can use more than one tag. However, in that case you must use tags with long delay times so that tag transmissions do not overlap or collide with one another. After a period of time, collect the data and determine the percentage of transmissions that were detected over representative time periods for each range. We recommend that you use a tag designed specifically for range testing. We have tags with a special end cap that allow you to easily attach to your mooring line. Do not attach or tape the tag directly to your main mooring line because you may notice reduced range in this case. For a first test, we suggest that the tag not be placed on or too close to the bottom or too close to the surface. If a tag is too close to the bottom, then ridges or boulders may impede the signal to the VR2Ws and the results may be very unpredictable. If it is too close to the surface, then bubbles and waves might have significant absorption and scattering effects on the signal. In this case, you may see results that vary with wind and wave conditions. Try to locate your VR2Ws in quiet environments and in locations where they have acoustic clear line of sight to expected animal or tag positions. Be aware of and avoid bottom topography problem areas such as troughs, mounts, reefs, etc. that might prevent the VR2Ws from hearing your tagged animals. These obstacles can affect your range data in such a way that it can be very difficult to understand your results. If you are doing a long-term range test, you should first do a short-term test over a few hours or a day to make sure that your setup works well. It is useful to have a VR100 tracking receiver to assist in your range test. The VR100 gives you a quick first view indication of the approximate range that you can expect. Usually VR2W range is less than what you'd get with the VR100. The VR100 can also be used as a diagnostic tool when results are not as expected, and you can also use the VR100 to listen for background noise emitted from various sources. Also, you should tape a weight to the cable just above the hydrophone so that the hydrophone lies vertically at least 2 meters under the surface. If you are in a deep-hulled boat, keep in mind that the hydrophone should be extended under the hull. Do not attach anything directly to the hydrophone itself. It is also useful to use a data logger like the Vemco Minilog to check for the presence of a thermocline. Sample temperature from the surface to the bottom, use a string of mini-logs on a measured line, and sample for a minimum of 10 minutes, or very slowly lower and raise a mini-log TDR, temperature and depth logger. Keep in mind that the mini-log should be lowered in depth increments for approximately 1 minute at each depth. Sampling rate should be 6 samples per minute or greater. Time synchronization is very important because you need to correlate all events that you record in a notebook to the data in your receiver files. This is even more critical when doing short-term tests where changes are being made within several minutes. If you have a VR100, you can use the onboard clock to synchronize your PC and watch. The VR100 clock is very precise as long as it's getting GPS signals. You can also use a GPS handheld. If you don't have the time to do a long-term range test, you can compromise and do one or more tests. However, try to do the tests in calm to rougher conditions to give you a range of environments and oceanographic conditions. You can theoretically get away with using random delays for your tags, however you need to be acutely aware of two things. First, be careful of collisions or ping overlap. If you are using more than one tag, the signals will occasionally overlap depending on the number of tags and their delays. If your collision rate is significant, your results could be meaningless. And second, you should have a VR2W close to your tag so that you can record every tag transmission. Otherwise, you'll not be able to calculate the percentage of detections logged over short time periods. There are some alternative setups that you could try if you are unable to do our recommended long-term range test. You could use several moorings of tags and only one mooring with one or more VR2Ws on it. This design can work, but you must pay close attention to using the right tag programming. You must use long delays, usually a few minutes or so apart, and the delays should be random, but the random window should not vary by much. For example, using delays of 280 to 320 seconds would allow you to still quantify how often the tag transmitted compared to how many detections were logged. If you want to use this design, please call us for advice. The most basic range test would be to take one mooring line of VR2Ws and one mooring line of one tag, place the VR2Ws in one spot, and move the tag line every so many meters every hour, enough times so that the tag will transmit many times. For example, a tag with a fixed delay of 5 seconds would transmit approximately 400 times per hour, and that would be a good delay to use. Another variation might be to moor 3 or 4 separate lines of VR2Ws and moor one line with the tag. After 1 hour, move the tag line closer or further away from the VR2W line. In 2 hours, you would then have 6 to 8 different ranges to analyze. Once the data is in view, our VR2 database software, you can query and view your range test data. If you are using a range test tag with a fixed delay, you will see a screen similar to the one pictured here. Your detections will be spaced by a constant time interval. You will find that data spaced by a fixed interval is easier to analyze because you can calculate the time when the tag transmitted its ID code. The next step then is to export your data and import it into a spreadsheet program. Most users prefer the comma-separated values format, or CSV. As mentioned before, it is best if you use a tag with a fixed delay so that you can easily count the number of tag transmissions in the time of your test and divide that into the number of log transmissions to derive the percentage of transmissions recorded for each distance from the VR2W. For a long-term test, we suggest that you choose a discrete time period and calculate the percentage of log data for each period. The period should not be too short or too long such that you mask the oceanographic and environmental events that affect range. We suggest 6 hours, however you decide what is best for you. Simply plot the percentage of transmissions logged against distance from the VR2W to give you a range graph. This is what a typical long-term range graph might look like. You should see more variability in the data as the distance from the VR2W increases. This is due to varying environmental and oceanographic conditions, which will influence range more widely at further distances from the VR2W. A short-term test will likely not show these differences. This is an example of how noise present at the VR2W receiver can lead to fewer detections and reduced range. Snapping shrimp, toadfish, and other sea life such as dolphins and whales can create noise underwater. In order to decode a transmitter under high noise conditions, the VR2W needs to hear a stronger tag signal at the same range when compared to quiet conditions. The graph illustrates that the VR2W was able to detect more tag transmissions during the day when snapping shrimp are quieter than during the early evening. The effect could be subtle, where range is slightly reduced, or you may notice very few or no detections in high noise environments. Without understanding the cause, you might find these results disappointing. However, understanding these phenomena can help you look for solutions. In this case, the user moved the receivers 100 meters further away from the reef and shrimp areas and noticed a dramatic improvement in detection range. Here is a sample recording of a snapping shrimp. This is an example of how echoes can affect the detection of tags at close range to the VR2W. You might end up with a graph that shows detections increasing and then decreasing as range increases from the VR2W. In this case, the VR2W is detecting echo pings as the transmitted signal bounces off a nearby rocky shoreline, a bedrock ridge, or a concrete barrier. The receiver cannot decode the ID, and the results indicate a lower detection percentage close to the VR2W. The cause of this is explained in greater detail in our FAQs on our website. This phenomenon should have little effect on overall array performance, since a fish can't pass through this null area without crossing large areas of high detection probability. In most cases, simply moving the VR2W closer or further from shore, or using a tag with lower output power, can completely remedy the situation. Please remember that regardless of the type of range test you are planning to conduct, please contact us for advice prior to setup.